introduce Whisker.
Okay.
And you like On va commencer. Merci, bienvenue chez Whisker. Il y aura un petit buffet offert par Whisker à la fin de la présentation de Ken. Je vous souhaite une bonne soirée et à tout à l'heure.
All right. I would continue this in French if I knew it. I probably couldn't get close. As a help, I'll try to just slow down my speech in general, just because I understand the barriers a little bit. I'll start by saying this city is amazing, and I need to come here for much longer. Clearly. And everybody here has been very warm, so we appreciate it. I couldn't come to the city of love without mine love, so that part of this has been amazing. How many people are using Mesos in here? Anyone? Apache Mesos? Okay, a couple. This meetup and my presentation is geared around something new. The Dcos, which is the Datacenter Operating System. I am open to having conversations about much more than that if you'd like. So I have either slide materials, probably, or I could just, we have a whiteboard. So feel free, we'll go into more details if you'd like. Also, I can almost always go deeper than whatever material I have, meaning technically deep. Occasionally I get into places where they want to go on the business side of it, and if you have business questions around value proposition, we can talk about that as well. So my name's Ken. There's how to tweet if you want to. There's a Twitter handle for Mesosphere as well. That's the company I work for. 2 years ago, roughly, maybe a year and a half to 2 years ago, I was asked to lead up a research and development department within Savis, which is a part of CenturyLink in the United States. That ISP, from what I understand, is about the third largest in the country, so it's reasonably large. But from a cloud providing standpoint, they were very immature, and they were looking to compete with the likes of Amazon, and they were nowhere near, right? They weren't even close. That was an interesting time. During that process, it became clear there were a couple of things, there were a couple of technologies that were leading in the field. They asked me to predict what would be the future of the cloud in 2 to 5 years, which is ridiculous, right? As just humans being able to predict the future is terrible, but do it in the technology space, it becomes worse, right? It's really ridiculous. Thing is, though, I am shocked at how what we were able to uncover then has really become true now. Lucky? I don't know. But I've been in the technology space for a long time. I've been a consultant since around '98, so I've been doing this for a little bit. When we made the predictions, it was there were 3 things that stood out. 2 of them I work on pretty regularly now. One was Docker, and at the time it was about version 0.3, getting into the 0.5 timeframe. So that's about the timeframe of it. It was last year. The other was Mesos, and the third would have been CoreOS. I'm doing less with CoreOS than that part I'm doing less with than the other 2. Although Mesosphere has a partnership now with CoreOS, so that's pretty cool. A little bit off topic, but if you have been watching in this space, CoreOS just announced Rocket, which is a competing container. And we're beginning what I'm going to refer to now as the container wars. We'll see which one survives. We've been doing containers for a very long time, though. If you look at Solaris, and even things that predate that, the concepts of C groups and isolation and containment have been around for some time. Docker, though, has really added a couple of really large value adds. The biggest one being the file format. Creating the file format, having that defined and standardized, and creating a repository or a hub in the cloud is a really big deal. It's really brought technology to a space that's make it available to everybody. When I joined Mesosphere, which was this last year around the summertime, they said that we were a product-based company and not a service-based company. So many startup companies around open source will provide services to whatever the open source product is. It was hard to see that initially. And we are going to be talking about product, but at the same time, this product, in large part, will be open source. I don't know how much of that will not be open source. That has not been completely determined, but there's a good portion of it that will be open source. So we're talking about things that are built on open source, and then many of the things that we're talking about will be open sourced as well. I'm also going to be showing you some things that the infrastructure is real, but there is some mocks. There's some mock services that will give the impression of what will be possible. They don't exist yet. They will be built out over this next quarter. So we are heavily involved in trying to build that out today. So with that, I will start a little bit. The DCOS is referred to as the Datacenter Operating System. We get a little bit of flack on that, in that people want to compare this to a PaaS solution, a PaaS solution. When you look at a standard data center and the different topologies we tend to see, the first you will see is an IaaS, or an infrastructure as a service. So we're talking about infrastructure, where you don't have to worry about, virtual machines are managed for you. Sometimes you don't have to worry about the OS. Sometimes you do. It varies a little bit there. The next layer of the stack would be a PaaS solution. And then past that, of course, a SaaS solution. But in the PaaS solution, that's what we could compare it with. And interesting, I don't know, we don't have really a take on that. If you were to look at Wikipedia, though, and look at the definition of operating system, it will talk about software that will make available to standardized applications resources, memory, computational power with CPU, and that's exactly what this does. And in fact, if you were to rip out a node or rip out a computer and just leave it a little bit abstract, or you could put in the word data center, it would still make sense. It would still be readable. And so that's our take on it. Our take on it is that the data center needs a new operating system, needs a way of managing a whole data center. What's the difference between putting multiple cores on a board or putting multiple cores across multiple boards? There's not terribly too much difference between that, right? It's a matter of how you want to lay out boards and cores. So our perspective on it is that it's truly an operating system. Now, there are some differences. The differences you could get would be things like you may have some analytical tools, and those analytical tools may want to land on a resource, on a node, that has specialized hardware. So you may want to land an analytical service on something that has JBOD or an SSD card on it. You may want to land it on a node that has a GPU on it. So now you get into very specific things that you want to be able to take advantage of, but it's really no different than landing a new card inside of a computer and saying, okay, I want a driver for that, and to be able to manage that in a certain way. So with that, the question that I have for you is, when is the last time you executed on your laptop? You're trying to start up a browser, and you were prompted with this. And the prompt is, okay, any modern laptop today would have 4, maybe 8, up to 16 cores in it, right? Very common to have 4 and 8. When's the last time you were asked which core would you like to run on? Yet today, in the data center, this is the very first question you have to answer. The very first question that you have to answer is, what processor affinity do you want? How many cores do you want associated with this thing? What is the name of the node that you would like this to land on? In fact, I refer to it as the legacy data center. It sounds strange, But we will be looking back from the future on now, going, that is the legacy way of thinking. What we've done today is we've taken tooling like Chef, Puppet, Ansible, Salt. These are all recipe-based tools to automate what we've been doing legacy for a very long time. Right? We've automated the pain, but we haven't really rethought that process. We haven't thought about, okay, how can we change that to be more intelligent? So the concept of a data center operating system is exactly this. Why is it not possible for us to start up a service in a cloud solution or a data center and not have to ask or answer this question? Why can't it just be scheduled for us as if it were on a computer? Right? It's possible. In fact, it's possible today. We could build it, but we're going to take a look at it. Another way of looking at it, at the kernel level, we would talk about Linux and BSD. You could program against the kernel if you like. You would be doing low-level programming in C or assembly language. You'd be building something against the kernel, and you'd probably be building a driver, right? Most of our applications do not have the needs that a driver has. We don't tend to program at that level of abstraction. It's usually a higher level that we program our business applications at. Most operating systems also have something that is their init system. So initd, System 5, Upstart. System D is one of the more current ones or modern ones being built out today on CoreOS. And then we have our applications based on that. So this would be looking at a single node in our traditional sense. We could take that same exact concept and move this into the data center, and we replace that kernel with Mesos. Apache Mesos becomes the kernel of the data center operating system. Yes, it needs an operating system underneath of it, or it needs virtualized machines underneath of it. The best part about Mesos is that you don't care and you don't know. It's a perfect abstraction, meaning you could be in a cloud solution or you could be on bare metal, and you don't know and you don't care. The other beautiful part about Apache Mesos is once you've deployed a set of applications on Mesos, to move it from one cloud to another cloud is nothing more than making sure that Mesos is installed on the other solution set. That's it, because once it's run in one set of a cluster, as long as the logical components like SSDs and GPUs and other resources are available in one versus the other, it's the same deployment. You're abstracted from it. And then within this ecosystem, Marathon is our init system. It's the thing that starts other things. And in fact, within Mesosphere, we have two frameworks, we call them, that sit on top of Mesos. One is Marathon, the other one's Kronos. It's very common in our high availability topologies to launch Kronos using Marathon. Everything within the DCOS is launched through Marathon, essentially. It's the init process. It's the thing that when a process fails, it would be restarted because Marathon says it should be running. And then we have applications that are running on top of that. I'm going to switch out to some slides, actually, because I think it might be useful. I don't always do this, but and I won't spend too much time on it, but I like the idea right now, based on where we're at, to kind of talk about where we are with the legacy data center and what I mean. And then I'm going to drive right into DCOS. So the first is the legacy data center. What is it? You could define it right here. It's statically partitioned. And what do we mean by statically partitioned? Typically in the data center, you have a bunch of hardware. Here we see 16. You slice and dice hardware into virtual machines. We do have the concept of over-provisioning, but at high scale that fails. So most of the time you do not over-provision. There are times when you might. So that means that each one of these is allocated a certain set of resources on each physical node. When we have a statically partitioned world, we could need to run Hadoop. In this particular case, we took 9 of those virtual machines, and we said those are going to run Hadoop. in the legacy sense, we say that's Hadoop 1, Hadoop 2, Hadoop 3. They actually have names. They're like pets, right? We take care of them like pets. They have names. We say then within this ecosystem of this cloud, then we have 10 nodes that are going to be web services, Rails, Tomcat, some kind of web service. Doesn't matter what it is. Maybe it's just NG, Nginx. When we want to allocate more, so we need to scale, we then we consume more virtual machines. This is the traditional sense of how we run the data center. And it's very problematic. We could go through a number of problems. The biggest problem is that there are humans involved, almost always. You could automate this process, but there's humans that determine certain elements of it. The other is, and the driver for this that we like, in particular administrators like it, is we have known IP addresses and known ports. I know where the thing is. If I have a problem with Hadoop, all I need to know is it 1 through 9, and then I can go to that box. I can start to understand what's going on. I need to know, right? Because what I'm going to say is that the future data center, you wouldn't know. You have no idea what node that landed on. None. You have no idea what service, what port that's at. And then you're left with questions. How do I debug it? How do I fix it, right? And I get that. It's understandable. It's reasonable. But we need tooling to solve that. That's not a, it's kind of the tail wagging the dog situation, right? I'll explain in a second. We talked about that. Resource utilization. This is a very typical set of curves that you have. When we talk about Hadoop, we could say that's really analytics. It's very common to have analytics kick off at night, usually on off-peak time. We're using as much of the resources available on our off-peak time. We have some kind of flat cache, and we have a curve of off-peak time to on-peak time to off-peak time with our web traffic. The question is why can't we bin pack that onto one node? We don't do that because we coupled two things together. The two things we've coupled together is scaling with capacity. Does that make sense? It's very common that if I'm going to spin up another web service, if I need to scale it, in other words. In fact, let me pause for a second. It's very common in our data center that on a given node, we will set a threshold. Different data centers, different administrators will set that threshold differently, but usually 75 or 80%. When you hit that mark, either CPU or memory, pagers go off. Oh crap, right? Other words are usually said, but okay, we have that oh crap moment. That means by design, we have 20% of our data center as waste by design. Because as soon as we hit that threshold, we're going to spin up another node. So we've tied two things together. The two things we've tied together is if I'm on Amazon and I need more scale, I will take an AMI image and I will spin it up. And I've added more capacity and scale at the same time. Those are two things that do not need to be coupled together, but traditionally they have been. So it's just a different way of looking at the solution, and you'll see what I mean as we start to play with this live. If you haven't looked at it, there is something in 2009, Google came out with something called the Google Borg. It was secret at the time, and it's well known today. They have replaced this now with something called Omega. They've been working on Omega for the last 4 years. It is not completely taken over where they thought it would yet. The Borg is essentially this. Google looked at their data center. They knew they had web searches that would have peak times to them, but they had a lot of idle time. The top portion of the data center, in other words, the top portion of non-used resources. Those are resources that could be used, but need to be used by the web traffic if necessary. But if they're not being used by web traffic, we should use it for other things. That's what the Borg is. The Borg was taking a look at consuming the entire data center to 100% using analytics for all computational power that was available that wasn't web search traffic. And in fact, Google has the most experience out of any company that I'm aware of with containers. And so when we start talking about Kubernetes, that might be worth looking at and listening to them. They do have some experience here. That's not to say the people that are working on Kubernetes have that experience, but the company has that experience. So careful to delineate those things. Okay, so I added some slides. I don't know if I want to go through all of them. There's another one worth talking about. Oh, you know what I wanted to get to? Let me jump out and get to my next talking point. Let's talk about the trends of the data center because it fits into the data center operating system, I think. The first is that the previous trend, the previous world, we would take an application, maybe a Ruby on Rails, Tomcat instance, we would throw that in a VM, and then we'd spin up an instance of that VM. So what's living in that VM is one thing, it's one service. It's a very common thing to see. You might have multiples, in fact, but the whole point is that a given server is virtualized and we have multiple apps running on that. The new world, the trend we're starting to see more often, very common in fact, is an application that aggregates across the data center. So Hadoop would be a great example of this, or Cassandra would be a great example of this. When you have a Cassandra ring, you have a number of nodes that participate together for a common purpose, a common goal. So we are now aggregating, just as we talked about early on. We could put multiple cores on a board, but we could also put multiple cores with multiple boards, all collaborating together, and that's what we see today if you look at it the right abstraction. I realize it's hard because we're still kind of forced into that legacy thinking, as there's a barrier here. I don't want to talk across this line. There's danger here, there's latency here. I don't have the same latency at a L1, L3 level cache versus hitting another machine. I get that. And those are reasonable things to consider, but we can start, we have applications that are aggregating things together and with good value, good reason. So this is talking about the aggregation of things and isolation of things as well. The second trend that we see is containers. As I mentioned early on, it's nothing new, but Docker really has taken off. And they've made something that used to be really challenging to do. If you were doing LXCs on your own before, it was a little bit of work. In fact, it was quite a bit of work. Unless you're using like Heroku. Heroku's been doing, their dynos essentially are LXCs. So there were people who have made this easy before. They just, frankly, it'd be interesting to know what the world would look like if Heroku had open sourced the technologies they were using for their automation. It'd be interesting to think about. But Docker has. They have essentially since then have left LXCs and have moved on to libcontainers, but it's irrelevant. It's containers. Containers are a big deal. In fact, from a virtual machine standpoint, one of the challenges we can't ask a virtual machine what changed in it. So you have an admin that woke up at 3 a.m. because pagers went off. They're doing the right thing. They're firefighting. They're fixing the problem, right? And then they go back to bed because they fixed the problem. What did they do? You can't ask the data center what happened. You can't ask the virtual machine, even if you knew which one it was, what happened. Unless you have tripwire. I mean, we have some technology to do some of that stuff. But containers provide some really neat abilities where we can get metadata from it. The other thing that's most important here, I think, is that containers, virtual machines consume somewhere between 7 and 15% of your data center just by the hypervisor and the guest OS that's necessary to run the virtual machine itself. So there's a certain amount of consumption of resources by the fact you're using virtual machines. And I'm not saying they're a bad thing, I'm just saying it's true. We've seen, for Mesosphere, we've seen some customers get rid of virtual machine licenses altogether, go bare metal, and have gained a higher performance and more resource. If you think about it, a large enough company with a large enough data center, if they were to gain 10% of their data center, that's a lot of computational power. It's a lot. So we've had some very, very large companies, which I can't talk about names, but you know who they are, I guarantee it. And the benefits that they've had are phenomenal, besides the fact that they got rid of their virtual machine licenses. So there's some real value to that. I will say this, just because we want to be fair about this. Containers, any container technology that I'm aware of has challenges in the space of security. So if you need a multi-tenant world and you need the highest level of isolation and security, you're probably today stuck in a virtualized world. With that said, there's a new project that started last fall, around October, called LexD, and it's LXD is the full name of it, but it's pronounced LexD. And it's intended to be a hypervisor for containers. So a different stack, same purpose, and its purpose is for isolation on containers. We'll see where that goes. I will say that Docker at DockerCon EU shot a shot across the bow and said that stuff's evil. So, like I said, container wars are on, right? It's we'll see who wins this. Yeah, I don't know if that's useful. The power of containers really is about immutability. It's the fact that I can always spin up an instance of something exactly how it was when I first saw it. It's a big deal. When I look at containers, it's all about immutability. In fact, as soon as we could no longer maintain the trajectory of Moore's Law, as soon as Moore's Law was broken, right, where we had so many chips going on, we couldn't make the die any smaller, power problems, all kinds of things. You saw in our world, I'm a developer, so in our world, you saw a movement from more OO practices to more functional practices. This was true with Clojure, and there's just a growing number of people learning about functional programming. And in that space, one of the most common concepts is about immutability. And when you get into concurrency, it's a very powerful concept. So there's value there. Interesting thought, and this will bring us right in, and I'll switch back over to my slides on this DCOS. This question on Stack Overflow, sorry, is a very common one. Any developer looking at Docker is enthralled by it. They're like, wow, this is cool. And it is. It's really cool. But then you're left with this question, which is, well, how do you get this into production? And different companies are struggling with this question, essentially. And there's, of course, options out there that are Docker supported. We think we have a good option for that. I'll just say that. The power of Mesos is that Mesos has been in production at Twitter for a number of years, and it's at high scale. We're talking tens of thousands of nodes. So with that, like I said, I'll switch over to my previous slides. Excuse me. So I'm about ready to get into demo mode because I would prefer that over slides. Challenge, though, I have noticed the last time I was doing some presentations, there is some latency across the pond. The pond is big enough still, or going to space or something, I don't know. There's some electron that's slowing us down. But usually it's been okay, so we'll see what happens. The DCOS for us is based on Mesos, based on Marathon. Kronos is our cron, which is awesome, right? When we get into a cron, for most organizations, it's very common to use cron. It's a single point of failure. It's one that many companies will figure out how to tolerate, but it is a single point of failure because it's only one machine that if it were to go down, the cron is no longer available. When we use Kronos, we have cron type capabilities, but in a distributed fashion and in a high availability. And for storage, we have Hdfs. Of course, other storage options are available. We've just introduced, I think a week or two ago, Mesos DNS, which is our approach for managing service discovery. There's a couple of different ideas and concepts there. I'll try to show off and demo some of that as well, since it's so new. Slides. All right, let's look at stuff. You know what I'll do first is open it up to any kind of questions someone might have, and then I'll drive into this. Is there any thoughts or questions on what we've talked about so far? Just Mesos, kind of the value of it, where it fits into the ecosystem? No? All right. That's pretty low font. All right. So what we see here, let me clean up a little bit. Let's see here. I'm going to cheat a tad. Okay, so a couple of things. The first is, this is supposed to represent our data center. There are many things about this that are real, meaning it's working. We are working on maturing it, building it higher quality, making it more production oriented. One of the other things that we're really focused on is user experience. This is kind of a cool demo. What you see here is 20 or 21 nodes up. You can see each donut is a node. So if I were to hover over a given donut, you'll see that that node has 13 gigs. Well, it's hard to read probably in the back, but it's 13 gigs is what we have for memory. I'm currently on the memory tab. You can see that I have a node here that's using 2%. Again, it's pink. We have certain colors that, they're not me. But I'm not the pink guy, I'm more of the blue guy. But Kubernetes is running as our blue color. Our pink color. The pink color is consuming 2%. So I started up a Kubernetes service before we engaged in conversation here tonight, just to show that, hey, we're running that. So step one, Kubernetes, which is really associated with Google as a solution, it's really an opinionated way of running a PaaS solution. Okay, an opinionated way of running a PaaS solution, which we totally think is cool. It's a PaaS solution based on Docker. I should make that more clear as well. The way they've built it out to run on Google Compute Engine. So they are going to provide that service on Google Compute. But they've also open sourced their technology. We are running on Google Compute, so that makes life a little bit easier. But I'm telling you that it is possible to run this on anywhere we could run Mesos, because between Kubernetes and Mesos, we're running the Kubernetes Mesos layer, which allows us to run anything Kubernetes would do. So the kind of opinions you get with Kubernetes is service discovery is one of them. Service discovery, I forget the actual number, but you get like a slant 24 of IP addresses on a given node. You live within a pod, so they have new terms, and a pod is a place where you could have multiple containers living in it. Within that pod, you would have essentially NATed IP. All containers share that IP address. And you know what? For certain levels of scale, for certain applications, that would fail. I'm just telling you that's true. At certain level, there are certain types of applications for which that opinion would fail. But there are plenty of applications for which it would be awesome. The other part of it is you can either choose to go Kubernetes and all in, meaning that's all you're going to do. You're going to transform all your applications to work on Kubernetes, or with using it with Mesos, or in this case, the Dcos, you could have applications that are built on Kubernetes, but also live with other things like running in Hadoop, because we'll also run different versions, in fact, of Hadoop on top of Apache Mesos. So it's a very cool technology. We'll take a look at it in a second. As I said, each donut is a node, and I could switch that out from memory to looking at CPU. You can see that that Kubernetes service actually consumes a quarter of the CPU available on that node. So we have a general picture. This is pretty cool, right? I can look at my entire data center. I can see what's going on with it. I can look at the memory. I can look at the CPU and see what services are being used and how they're being used. Now, if we were to really think about this, this could be a usability problem, right? This is super cool. I like it at this scale. But what if you're at Twitter and you have tens of thousands of these donuts? Well, now you need a way of either consolidating a number of donuts into an icon, or you need something, right? So those are the kind of things we're thinking of is, hey, our usability, imaginative experts, how do you convey this idea and thought? We haven't thought all those things through yet. That's what we're working on now. We're also building out real services. So there's some services in here we'll start up, and they're really just mocked. They give the idea, concept of what's going to happen, but clearly there's some maturing around the Cassandra framework that we'd like to see, among others. So, all right. So the other part that I left off is looking at the overview, and this is just the entire data center. Now, how cool is that? I can see the entire data center. In this case, the amount of CPU. I could switch over and look at the amount of memory as well. Now, we have so little that it's not interesting yet, but let's make it interesting, right? When we get to the Dcos, excuse me, we should be able to do things like, I want Dcos marathon. I want to start. In this case, I need to tell it what to do, so I'm going to go to a demo Rails app. If I have one, there we go. So I've just deployed a Rails application into the Dcos. If I were to move out, you'd see that marathon is this more rich blue color. Again, it's hard to distinguish between these two. But I'm using 10% of the CPU and 19% of the memory of that particular node. Scaling something then should be just as easy. And what you're missing is, I obviously said marathon start this application that is defined in a JSON file, right? Here's the cool part. If you're already using Mesos, it's very common that you're either using Marathon or you're using Aurora. Thank you. For some reason, I was struggling with that. That's not a good thing. But Aurora is essentially, those two are competing frameworks that do similar things. One is really behind, Twitter's behind heavily, has some Twitter elements to it. The one we're behind really is Marathon. But, so if you already have applications that are being deployed with Marathon, then they would work in the Dcos. That's it. We can go in here and say Dcos, Marathon. Now, at this particular case, you know what? Let me do this as well. I also have Marathon up, and Marathon shows that application, which is named Rails app, and you can see the amount of services that it's consuming. That I have one versus one up. Let's go back to the data center view. Excuse me. Let me bring this down so we can kind of see things happen at the same time. Marathon, scale, the Rails app to 15. So that was me telling that the Marathon that in the Dcos that I want to scale that application up. A couple of things we see here, first of all. First is that I've driven this from a command line, which is way cool. The second is I get an instant visualization on what's happening in my data center. The third is, I had another thought there. Yeah, that's the main points. So I can see the transformation in my data center instantly. I get some instant feedback. I see how things are being consumed. I can control from the command line very simply. Oh, that's the other thought. As you can see, what I was referring to before is I have a complete disconnect between scaling and capacity. I didn't add more to my data center. I didn't spin up another virtual machine to increase capacity and also increase scale. All I said was I needed more of this application. I've only scaled it. I did not add capacity. That's a completely different concept, right? Which we will also play with in a few seconds. So I think that's a very powerful concept. You can see a couple of things just based on knowing how things are working. Two of the things landed here. One landed here, one landed here. So you have a general idea of the applications and how they're landing. I can again hover over any one of these and say that 1 gig was consumed and I still got a 1.6 gig remaining on a given node. I can instantly see things at a node level or data center level. All right. The other cool thing is we have a list of services. Again, the best analogy I can make with this, but I get kind of some snickering when I usually do it. But if you look at the iPhone and what made it powerful, Apple created something really neat, but none of us would have bought it had there not been apps. Like the whole concept of there's an app for that is really cool, right? It was a great marketing trick. But the other thing is that Apple didn't create all those apps. Developers did. They created a whole developer ecosystem to build apps on top of that platform. What we're looking to do is to drive exactly that. You should be able to look at a given application and have a best practice associated with that particular type of service, and that should just be baked into a given recipe or a given framework or a given service. On top of that, of course, you need some configurations. We're working on those details as well. And what you see here, the underlying technology, if you're familiar with your Mac as a developer, I would assume that you're probably using Homebrew or Brew. That's what I do. It's the same kind of thing that we're doing. We have a repository back behind GitHub. We have some descriptions that are being managed in certain recipes. Those recipes will then pull binaries from certain locations, all of which can be privatized in a private data center if you needed to. So all of those things would be true. So being able to get Hdfs, if we wanted to install it, what would we do? From this standpoint, you know what, let's do it the easy way for this example. Hdfs, just drag it onto the command line. The command is dcos install Hdfs. So that then installs Hdfs, right? And again, the same thing, I need a Cassandra, right? Now some of this seems a little bit crazy or maybe ridiculous, but the reality is that is our goal, that's what we're after, that's what we're doing. So now you can see that I've added a Cassandra service, literally added a new service in. What are the things that are happening here? Well, whenever you have an Hdfs service being added in, you need data nodes, you need naming nodes. There's got to be a service that has the best practices around how is that managed? How do I provide high scale for that? How do I land this? Do I have it on if I have another data node, do I make sure they're on different nodes? And how do I do that? That logic is all in the service itself. So there's work to that, right? There's some serious work. Will one recipe or one best practice work for everybody? Yeah, probably not. But will it work for a great many of them? To install Cassandra or Hdfs in an entire data center, if you know what you're doing, could take several days. If you know what you're doing, that's best case. And we want to make that a command line or a click away, right? At least the start of it. So that's our goal. So we can see how easy it is to create given services. Now, I could go on with a couple of other scripts, but one of the more fun things to do is to say, you know what, dcos chaos 5, and I'm just picking a number. This is the thing, there, it happened really quick. The latency was so slow before that the fun didn't happen visually, which is depressing, but this is fun. So we added in chaos, very similar to Chaos Monkey, to knock out nodes. What you see happening here is that a node that was knocked out with a service that was running was reprovisioned automatically to the given available service that were online. So that just really shows off what already exists with Mesos, frankly. And, well, I should say Mesos plus Marathon. It's Marathon that's doing all the magic, really. When a node goes away, it's detected by Mesos. Mesos then indicates that to Marathon, and then it offers Marathon other resources. And then the other real powerful thing, and again, this becomes data center and cloud specific, but we're trying to build an abstraction layer that allows us to be really easy to do, is to do Dcos Resize, and I want to resize my data center to 10. So in this particular case, we should see nodes just collapse down from 20 into 10 nodes that are available magically. Now, this is not the likely case. Hopefully your business is doing well and you've increased the number of nodes as opposed to decreased them. But you can see some power here, right? And the power is, I should be more clear about a couple of these things. Almost everything that you're seeing here, and in fact everything I can think of that we're doing on the command line, which is cool. We're seeing some things that are on the UI, which is cool. Everything's available through RESTful APIs. So you can detect it through your own needs. You can sign up to say, you could register to get events. Based on those events, you can do other things like add your own nodes. You could have the logic that increases the number of nodes through an automated process as opposed to a human process. The other really powerful concept is that I can disconnect capacity from scale. Let's see if we can refresh real quick and see if that happened. Like I said, sometimes the latency is just killer. Yeah, it'll happen over time. So I'm not too concerned with that. And in fact, here we could do. You know what? I don't kill anything yet. Let me jump to. Let me do this. Dcos Marathon. Start. I don't have it. Okay. So I just started an Nginx out there somewhere. You can also see that things just consolidated down behind the scenes while we were out doing other things. So now more of the data center is being consumed. Now all of a sudden the overview becomes more interesting and useful, where I start to see the entire consumption of resources at the data center level as opposed to a node level, which can be really useful. This becomes super useful when we've disconnected that capacity from scale. Now I just keep scaling, knowing I have enough nodes for fault tolerance. And now instead of 20%, that 20% alarm that I have on a node, for every node, I can have at a data center level as opposed to a node level, which is a really powerful concept. Right? And the literature that I've read, and I recently looked this up, says that most data centers do not use, it's less than 20% is what they consume of their data center. So utilization is less than 20% for almost every data center in the world, which is weird, but true. The question is what could you do with that if you knew you could use more of the resources available, because you could bin pack, because you have more services running on a given node than you're used to, just based on all the details we've walked through. So I went out to here to see, I have an Nginx app running, and there's a bug in this particular marathon version that I have on this data center. So forgive me on that. I went out here to copy this to give you an idea of what this is doing. Let's jump to DNS. And clear this. So we have Mesos DNS, and very few people have looked at this. All the details are online. It is open sourced and has been announced a couple weeks ago. The way this generally works is I want to search for marathon. So a couple things we need to fix. We can talk about it in a second. So I did a query. Let's look at that again. It doesn't fit within this resolution very well. I've scripted dig, and all dig is doing, we could go out there and cat the executable there, or the shell. But all it's doing is using dig against an at for this local machine. So it's just saying, hey, instead of just digging out there to any name service, look at this name service running on this node. And then take a look at Nginx. Some crazy number. That's what I had to look up for a second. The Marathon and then Mesos. This Marathon version has a bug where it's pulling out the ID for the Docker run that shouldn't be there. I think the version right after this is fixed, so 7.6 is fixed. I'm about ready to upgrade this machine to 8.0, which was just released and announced. We'd also like to see this version number go away. You shouldn't rely necessarily on the version. You should be able to upgrade Marathon without having names changed on you, right? But the general topology of this is the application, the framework, and then Mesos, and that'll be the lookup for it. The beauty of that then is I can query that, I can see that I have a response, and I can see that this service landed on that IP address. If I were to curl that at port, I don't know what port it landed at. Probably at 80, but we could do this. It's a little bit more complex, but it's worth trying out. You'd have to dig into the nuances of DNS to know all these details. It's kind of weird, but... Oh, one more time. There we go. So all I asked is for the service of that, and so we can see that particular service is running, and it's actually hosted at 31,000. So if we were to do a curl on that IP address at 31,000, we would then see Nginx respond back correctly. So there's a way of looking that up. Does that make sense? That might be foreign to a number of people, but I don't see too many people that familiar with DNS, but let's go back to this. I mentioned before that it might be useful to know where something landed. Well, here we're going to do a Mesos PS. we can see on a Mesos PS all the things that Mesos is running. So now I can see, the thing I might be interested in is I can do a Mesos tail on Rails app. Now I'm doing a tail on every instance of the Rails app that's running. This is standard out. I could do a follow on this, and I could pipe this. So I don't even know where it's running. And as you can look in our data center, that's not the data center. There's the data center. And there's the nodes. So if we look at our data center, I see that there's a number of Rails apps running. I can see that there's multiples on any given node in here. And I can do a tail and even a follow tail on standard out without actually knowing where it's at. Additionally, I could go into each one of them. Additionally, I could say I actually want standard air instead of standard out. And so now I'm getting a tail on every one of them at the same time. If I wanted to be specific, I could auto-complete to the exact name and deal with the one, right, if I wanted to. So that's cool. I can additionally go in there and say, you know what, I actually want instead to SSH into a Rails app. And then I could actually land inside the sandbox of that container and look at the details of what's in that container at that time. So the issue that we had with not knowing where something would land is we didn't have the tooling that would allow us to debug this thing, to manage this thing in a world where it's random, or it's pseudo-random, really. It's not exactly random, but it's somewhere in the data center, and it should be managed in a different way. It shouldn't be human managed, right? It's just a CPU, and it's just a set of memory somewhere in the data center. So I think that's the core of what I had. I think there's another demo. I don't know if I've ever run it though, on doing like a Spark job and seeing magic happen where all it's going to do is start up Spark and then use a bunch of resources across the cluster and aggregate it. But I'll open it up to questions if people have them. Any questions? The other thing I'll do and I'll grab that question, is give you an idea if I don't like to leave things abstract. So if you've never seen a definition of a job, it might be worth just taking a quick glance at it. If it's totally foreign to you, then that's what it looks like. And I'll walk through it in a second. Let me get the question. Yes?
And can you go deeper into the details of what installing means?
Sure.
What does it do when you install it?
You know what? Maybe. Let me see if I still have it up. I do. Nope. I do. There it is. This font may be terrible, though. Let me see if I can fix that. So in the demo that I did, the demonstration that I did, you could call that the alpha version, right? We made something work, and installation at that point really looked at a repository of definitions of services, and then it pulls the versions out of that and then lands it. It literally uses Marathon. So there's a JSON object that represents the job for the service, and it uses Marathon to launch that off. So it starts it, and then that service, because it's a framework, registers with Mesos as a framework. So that's the logistics. That, I think, answers the question. But since you asked the question, it was last Monday where our team showed off kind of the beta version, like a more improved, a more updated version. And this is the ASCII representation of that. I don't know if you've looked at ASCII Cinema, but it's a way of playing ASCII back and forth. And if we scan through it, we might be able to see, like, and this was real. Like, they recorded it just to make things easy because it's like it makes it a couple minutes. But here you can say, give me a list of packages, give me help. So here is the package. You can get the info. So what version are we at? Install, list, do a search. Anything you would see like with a brew, like a home brew. Here you can see, give me a config list. So what's the configuration I'm using? In this particular case, we're doing a grep for a given package. So here's the JSON objects that represent certain jobs or certain services. We would obviously support different versions of things. So those details are being added in. Here you can see that I'm doing a package install of the Mesos DNS. So we've moved DNS from being something you have to install on a given machine into here's how you would install it into the data center. If that's the service discovery approach you want to use, literally it will install. In this particular case, it's a little bit different. Let me pause it for a second. It's a little bit different because Mesos DNS actually registers with Marathon and not Mesos. No, actually, I don't know if that's true. Yeah, that's not true. It does register with Mesos, but conceivably we could register with Marathon and get Marathon events if that's all we were interested in. So this does an install of the DNS, but in this particular case, DNS needs specific things. Those things are provided in another JSON object for configuration. So now, not only did we install an application, but we've added configuration into the data center as well. So wherever that landed, it'll be provisioned with those configuration options.
If we take let's say the example of Hdfs.
Yep.
One of the options you have. So what exactly does it do? Does it download packages? Downloads the
Yep.
jars, I guess. And stops there. And when I say start Hdfs, then it start the main node and stuff like that. Is there something else in between?
Yep. I'm trying to see where it's at. I don't know if we'll find it. We just created I shouldn't say we just created. We've just improved HDFS framework for Mesos. We've done that over the last few months. Elizabeth was newly hired on our team. She's a Java expert, and that was her first job, was to work on that. So clearly, it will need a provision. It depends. And I don't know what ours exactly does, to be honest. So maybe I should pause for a second. With HDFS, you would need Java, each node. You would need a number of things provisioned, all the dependencies for that. But that's kind of the beauty, excuse me, of Docker. So we're starting to Dockerize a number of our services. And we are basing a lot of the technology that we're doing on Docker. It wouldn't surprise me, in fact, if the Mesos DNS was deployed through Docker, but I wasn't home to be able to see and get the details on that. That's what we've been talking about. And in fact, Docker, the latest version of Docker, opens up certain privileges that weren't there previously, that allow us to do things that we otherwise couldn't do through Docker. So a good example of that, I'm trying to think of the exact example, but we've got a number of services that we're not deploying today, but we've done in the past that would do some configuration changes to IP tables. That would not have been possible before, but now the rights are possible if you start up the Docker container with the right rights. So I don't know if I'm answering your question, but our target really is to Dockerize these things and deploy them through Docker. Then to further answer your question is how do you know where it landed? It is possible to deploy any container with Mesos to let's say that you always wanted it on every node. So you wanted data nodes out there on every node. So the constraint would then just be unique host, and then you would query the number of nodes that are in the data center, and then you would just say, I need this number. All of that driven by the framework though, right? All that driven by the framework. So all easily possible. I don't know where we are in the stage of that development, but I do know that we recently had a demonstration on our more productionized version of HDFS for the services that we use internally. So, yeah. Questions? Yeah.
Yes, thanks for your talk. Running persistent data services using containers is
Yeah.
still a work in progress, whether it's Docker or control groups or whatever you want to do. And I've noticed that in the latest version of Mesosphere that you distribute using Ubuntu packages, it comes with Hdfs pre-installed already. But in DCOS, are you adding something specific to actually be sure that when you're running a container containing this data, it's replicated, or when if a node dies, the data is still be, because it's okay to write that using Hdfs and Cassandra because they are replicated anyway, your data is always somewhere. But if you want a database, for example, it's not the same thing. You have a different set of problems. So are you guys working on something similar or not with the DCOS?
It's a great question. Shows a lot of understanding of where we are. So we have a lot to do to get DCOS out in a production way, like where people can start to use it. So I'm showing you a demo. It is live. I mean, the infrastructure is all real, but there's elements of it that still need to be improved in order to make it productionized. That said, storage, we had it listed there, and we had HDFS as the storage item. That's more of a stretch goal for us, and there's some reasons why that I'm about to go through. So newly added into Mesos, and I thought it would be last quarter, meaning last fall or winter, where we would have persistent offers as a primitive within Mesos. It hasn't landed yet, but it's supposed to be in the next version. After we have persistent offers available as a primitive within Mesos, then we can start to see frameworks actually leverage that primitive. So there's always a delay in getting the primitives in place and then allowing someone to use it. For those who are not aware, there's a number of purposes for the primitive offers, but the concept is this. A good example might be Kafka. Kafka will have a number of, a certain amount of data that it will store locally. And if you lose a node, if the node went down, you're just your host. Unless you're replicating data, there's nothing you can do. But if the service went down, the service had a problem and it failed and you need to restart the service, it would be really nice to say, instead of finding a random node out here for an offer to land again, it would be really nice to start Kafka on the same node that it previously was on, recovering any data that would already exist there. So that's the concept. That's part of the concepts of what's coming out with the persistent offers, is the ability to do that kind of thing. And when you get into persistence, as you mentioned, there's a lot of complexity in that space, things that we don't have solid solutions for. It's probably the worst component. Statefulness and state and persistence are one of the most challenging parts of a cloud solution in general. So we're working on it, but we don't have a perfect solution. What else? Even our Cassandra option, there's room for improvements there. So high on our list, like what we really want in place in short order from a persistent standpoint. A general HDFS solution that will work and be highly available within a data center. Cassandra, and those are probably the two. I feel like I'm missing one, but those are the two that stand out. Cassandra and HDFS are really important goals for us. Oh, and Kafka, that's the other one. We're working with the newly created company, Confluent, to work on the Kafka framework. So.
There are many frameworks actually run Kafka within Mesos these days, for example. One of them is Go. It has some issues, but it works rather well because you can specify the retention period within Kafka, so you don't have to keep your data long enough to do the same thing. You can initialize it. So it works well. I run Kafka within Mesos, so it works rather well using Docker and Marathon, for example.
Mm-hmm.
It works okay. But there's still room for improvement, especially for things like databases. It's a bit tricky to actually have there within to guarantee the long time that you want to keep your data. So there's still room for improvement.
Yeah. And it sounds like you might know more in that area than I do. So we tend to have two different groups in the Mesos world, it seems. One's kind of more analytics, and that would be Kafka, Cumulo, Spark, Storm, that world. And then the other world is more of a microservices world or a SOA world. And that tends to be the world I'm coming from, but I'm needing to know more about your world. So, but I do have a ton of people on my team that are in this space and working on that. So if you have interest or needs or concerns, let me know and get it to the right person. So. Any other thoughts or questions? Yeah.
Yeah, right now we run Mesos for a test, a large-scale test.
Mm-hmm.
And one of the issues we had more for microservices setup is Mesos really manages CPU and memory and disk capacity.
Say that again?
The resources managed and offered by Mesos are really CPU, memory, and disk capacity.
Okay.
And what if we need to control IOPS and network bandwidth?
Yeah, great questions. Yeah, really, really great questions. So I have good news for you. So don't I say good question because it is a good question, but not that I don't have an answer. So a couple of things that are worth bringing out. When you start up a slave, which is a term we give a Mesos slave that is just a regular node, one of these guys out here, it will, without any configuration, it will auto-discover things and then report back. And the thing that it reports back and offers are the things that you just mentioned. CPU and memory stand out. CPU controlled by C groups, which is the standard way that Docker does it as well, so everybody's doing the same thing roughly. Memory and memory constraints are managed again. And then disk. We can manage disk fairly well as well. Disk space, right, disk space. I could tell you that Groupon is working on a solution for managing I/O, and they have a very strong need for managing or isolating on I/O, and it's egress I/O, so outbound I/O, where you could say this container or this application gets 1 gigabit of outbound, and then it's constrained by that. So I don't know where that's at, but that's going to be added into this. The other thing that I will say is that you can configure any of that to the slave. So if for some reason you have an 8-core node and it is living with Cassandra as a great example on that node, living out of band, it's not controlled by Mesos, you would not want to ever starve Cassandra. It doesn't do good things, right? So you might say that this node from a Mesos standpoint only has 4 cores, the other 4 being left over for anything living out of band. So it's completely possible to under-provision, but it's also possible to over-provision, if that's what you were interested in. You've got to be careful there. But you can also tell Mesos, you can advertise any resource. So here are some great examples. This is one of the topics that I guess is advanced, but when you start to learn it, it's not an advanced concept, but it's so not known by the general community, it seems. And perhaps it just needs to be documented better. You can advertise any resource. So when you get into Hdfs and Kafka, those are 2 great examples of services that do a lot of, from an operating standpoint, they do a lot of thrashing of memory to disk. So you would not want those 2 things living on the same node, right? If you had a choice, you would not do that, because they're going to compete for that resource, essentially, and that resource is just paging, right? So what you could do is you can create an arbitrary attribute on a node, and it's actually considered to be a resource, not an attribute. And in the configuration of constraints, you could say this thing is going to consume 1 page. And if you only had 1 page on a node, then only a service, any service that doesn't require a page will land there. Any service that requires a page will land there, consume the page. Any additional service that needs a page could not land there because it requires a page. It's another offer that will be offered up by the slave. So you can create an arbitrary thing that will be there. Newly coming out with Mesos again, and I think the next version, but it's questionable. They're going to come out with dynamic attributes, which is if you were to land there, like as Hdfs, then you would say there's a new thing available, right? Or there's a new thing consumed. So there's a couple of ways you could look at it. But it's dynamic attributes. It's a way of saying that this node is hot, or this node has a lot of paging activity going on it, right? So if you had a number of nodes out there that had GPUs, and you considered this node to have one GPU, and I have something that consumes a half a GPU, it can only handle 2 services that consume a GPU, and any other service would not be able to land there. All those things are controllable. So if you're looking to isolate, it depends on what you're trying to isolate. If you're looking to isolate a node and paging, that would be handled the way I just described, and I could show you details if you want them. If you're looking to isolate I/O, that's much more challenging, and it requires isolation. I guess I'd call it a driver, but you need something on the machine to be able to manage the isolation. And that's being developed. So, yeah.
And another question, which is it possible right now to have 2 frameworks coordinate where they will land their module or whatever? Typically, I want to spoke Spark and Cassandra on the same node because I want to work them together.
That is
And but they are different
fascinating.
frameworks.
Yeah, that's a fascinating question. I don't know the answer to that, to be completely open and honest, but there is something within the Mesos primitives for being able to send messages. So your question really becomes challenging when it is, what's the coordination mechanism? It is possible to send messages, but I've never seen frameworks send messages to each other. But it seems possible, what you're describing. What else?
If everything is launched from Marathon, with Marathon we have a lot of controls on where we place everything because the constraints of Marathon are great. But all the other frameworks don't really use them.
Yeah. There's a couple of ways of coordinating, though, and you described one that threw me off, which is why I said it was fascinating. A common thing that you see people wanting to do was what I described when I talked about the Google Borg, and that is I've defined a set of services as what I'm going to call tier 0. In other words, they're guaranteed reservations, right? And then I have another tier, tier 1, which I would refer to, instead of guaranteed reservations, it's best of service, whatever's available, right? So let me give an example. Let's say you have your production web application, and it's super important. You want consumers to be able to get to your web page, and it should never fail. And you want to be able to tolerate a high load. So you say 75% of my data center is going to be used for web traffic. The problem is that you say I'm going to allocate, in other words, reserve 75% of the data center for web traffic. Maybe it's only using 20%, right? So you have another set of services, your analytical services, and they're best of service. What they could do, essentially, is consume 50% of the data center because I'm only using 20%. But then you need the ability that when web traffic increases and it consumes 60%, because it can consume up to 75, and we guaranteed that it had the ability to, right? When it moved to 60, I would then have to tell my analytical services that their offers have been revoked. So the ability to revoke offers has been newly added into Mesos last year, end of last year sometime, I forget, probably fall. But people taking advantage of that, frameworks taking advantage of that haven't really come to fruition yet. We should see it shortly. But that's what people are after. So you said coordination. That's not quite coordination. It's about, I call it cluster design, where I'm looking at my cluster, seeing how I want to annotate it or tag it, and then how I want to leverage it, and what's my best of services versus my tier 0 or guaranteed services. The whole collaboration of I want these two things to collaborate together, I'd say based on my current knowledge, what you'd probably do is either communicate out of band or more than likely use send messages. But most of the time send messages are used to communicate from like the executor to the scheduler, right? So talking scheduler to scheduler seems interesting. I've not seen that done. So what's that?
It's like, because I have a lot of questions.
Oh yeah. Oh, okay. You're yielding a little time. So he's yielding for a moment if anybody has a question. Otherwise, he's got more. Yes.
Let's say you have an application on multiple nodes, and what would
Yeah. So I don't know if I follow completely, but I got the concept that you have multiple applications deployed on multiple nodes or the same node. Doesn't matter. So it depends on what you're doing. It might be worth looking at this for a second. When you deploy an application, you know what? Just for simplicity's sake, I'm just going to talk about Docker. Is everybody all right with that? So Mesos has 3 capabilities of containerizing, if you will. One is it can launch off a shell command. So you can launch just a shell command, and at that point, you don't really have a container in place. It's just executing a command on a node. The other thing it can do, which it's been doing forever, is it can have a container, and that container we kind of just refer to internally as a Mesos container, but it's a C group controlled container. So we've had that for a long time, I think since 2009 or 2010. It's been a long time. Docker kicked off and became so popular, we added the ability, it's had a long way about. We had Deimos and had some other junk before that, and then Deimos, and then we added it in. We are also working on a Rocket integration. So being able to launch off Rocket will happen within Mesos. That's just part of the core. So just for simplicity's sake, I'm just going to talk Docker because some of the other containers might work a little bit different. With Docker, when you spin up a Docker, you have the ability to launch it into a host mode. When you do that, it will have a port, presumably, that will be exported or exposed onto the host IP address. So if we were working with Nginx, by default, it exposes port 80. It is a HTTP service. So if you said -- net equals host, it would then open up port 80 for that Docker instance. Most commonly, though, you will run Docker in a bridge mode. And when you run Docker in a bridge mode, the internal port is going to be port 80. It will have somewhat of a random port. It's not really random, but it won't be controlled by you, generally speaking. And essentially, port 80 will be mapped from that port. Whatever that port is, that's going to be your host port, right? The local host port. So when we look at this configuration for this Nginx and bridge mode, inside the container it's port 80. The host port is going to be 0, and that means pick a random port, right? So all likelihood on a freshly installed or freshly provisioned environment with Mesos and Docker, this would be 31,000, right? It's going to be 31,000. So the local IP address will be 31,000. And then we have this service port here. If you were to provision Mesos or DCOS into a cluster, the most common way we will front services is through HA proxy. But you could do anything. You could hook this up with F5 or whatever you want. What this says is take all the services that are running with Docker, with all their IP addresses, wherever they landed, with all the ports, which are randomized, and front them with HA proxy at port 80. So you'll literally see in the HA proxy config file the front end of 80 with an IP address. This kind of answers your question. With an IP address, and I could have multiple IPs I could have multiple entries of the same IP, right? So I have IP1, and IP2 with these two IP1s as 31,000 and 31,001. So I have 2 services running on the same IP. So if I have multiple applications, they typically will have, who knows what IP address, but there'll be some node in the cluster. I could have multiples on the same one. They, of course, will be at different ports. Those ports will usually be fronted by some service. And this art, or this technique of fronting a well-known service port to a bunch of unknown services is the most common way to see this done. This is exactly what Google does as well. I'm not saying they use HA proxy. I'm saying that they have a well-known service port that fronts a bunch of services that have pseudo-random ports. Does that answer your question? Yeah.
The HA proxy you were talking about, does it come as part of DCOS?
Yes. So by default it's that, but all these are configurable, yes. There's a new service. I don't think we've open sourced it yet, but it's not challenged. It should be out shortly. and it's nothing, I don't think it's terribly exciting, I'll put it that way, is something called service router. And the service router, let's go out here one more time. Mesos. There's a couple of products that do something similar. This one is hard to read. There are two that I think are really fascinating. Okay. There are two that I think are fascinating. There are three I'm going to talk about and two that I think are fascinating. The one that I don't think is fascinating is the one we provide. Inside of Marathon, there is a bin directory. Inside that directory, there's a script, and that script reads or polls Marathon, finds configurations, and then updates the HA proxy. So we call it the HA proxy Marathon bridge, or maybe it's the Marathon HA proxy bridge, but irrelevant, right? First of all, it's a poll. It's very common to set up as a cron, and that's a terrible way of doing it, in my opinion. It shows how to do it, though, right? It shows how to do it, but it's not the way to go. There was a hack week last week at MesosCon. The guy behind this, I forget his name. They're probably relevant. Pablo. I asked him to open source this, and lo and behold, he just did it. That's crazy, right? A week later, he's just open sourced this. It's called the Mesos Hub. This is all Ruby on Rails. It monitors HA proxy. It listens to Marathon, or polls Marathon. So it's polling. But its management capabilities of managing multiple versions of applications is so compelling. I think it's worth looking at. It is amazing. So in this particular model, what you'd have, we need to draw stuff, right? You would have like a bunch of services. Here we have three that are fronted by a port, and then you have but this is the back end port, and then you have a front end port. So then you would say this is the V1 of the application with all the services that support it. And if you need to scale it up, you create another one. So now you have 4, right? But you also have a V2 of the app with its front end port. So I have a front end, it's still a back end port, but I have all of these IP ports fronting these services. This port is the V2 port. All of these services fronted by this port is the V1 port. But then here's where the magic is. Within the UI, you can say, oh, the front end port, the thing that everything's using, is now switched to this. And switching from V1 to V2 at scale can happen in production. And they do some really cool things. So it's worth looking at from that perspective. It's really cool, and it's a very advanced way of using HA proxy. So, buyer beware, you need to be an expert at it. This other one is Bamboo, and kind of an overloaded term in the developer space, but this version of Bamboo is, instead of Ruby, which was the previous version, this is a Go application. The beauty of this is it actually registers with Marathon for events, and instead of polling, it gets events as things happen. So when an application fails and then starts up, it can then be managed from that perspective. To me, it's the more appropriate way of managing it. The new project that I referred to, Service Router, which isn't open source yet, does something similar. I also think it's written in Go, and it registers with the service to be able to work off the event system.
And kind of service register with Marathon to be notified of new other services that are up.
What's that?
Instead, can a random service register with this or Marathon directly to be notified of new other services that other. So instead of changing the configuration of HA proxy only,
Yeah.
can I know that new services are there and
You could. If that's what your interest is, you could. You could register with Marathon and you would see any. You could. Yeah, if you wanted to, you could, for sure. Yes. I don't know if that's what. I mean, there's a lot of options here, and people are going to pick different options for their different needs. For the highest reaction time to a new service being created, using Marathon's events is probably the best way to go. we're trying to go down the path of two options. One is the Mesos DNS. So any service being launched within the entire Mesos ecosystem would have a DNS registration entry being added into the DNS. So discovery could easily be done through DNS. It'd be very similar to like what Sky DNS does. So there's other examples of this being done in our ecosystem. When you're looking at Mesos DNS, though, for service discovery, that seems and feels to me like a mid-tier solution. From a front-tier solution, you still use HA proxy, where it's fronting and load balancing across multiple services ports. So, yeah. And some of that still needs to be thought out, I think, at least for me. It's not, there are things not completely clear in my head yet, so we'll get there. I say that because I would love to see entries in my Mesos DNS that are load balanced or fault tolerant, right? That's what I would love. But when you do a DNS query, you're going to get answers back that have everything, so then you have to manage it, and that's the thing. And then you have, broken things like Java. That Java's just broken. Java has had a bug since the 90s around DNS, I think. It caches the values that are returned, which is frustrating. Only because there's still a large percentage of development done on Java. So if you're going to cater to Java development, it's just a problem. So, any other questions? You have more, right?
What is, in your experience, what is the minimum size for data centers to be really interesting to have Mesos as an operating system? Because if you have a few servers, you're not getting the. First, it's very simple to manage manually anyway, and second, you're not really getting an optimal placement of offers because there's a bit of statistical properties for offers, so you need to have enough servers to really have efficient scheduling.
Yeah.
So, in your opinion, what would be the minimum recommended size?
That's a really tough question because I don't think I'm going to answer the question the way you potentially imagine me answering it. One of the things I love most about Mesos, the more I get into it, the more I understand it, the thing I love about it, for years, 2 decades now, that's a long time, the common way to have a startup company is you build the thing that's your advantage as a startup company is fast time to market. It's just being agile and being out there fast, right? So getting something out there is your primary objective. You're not looking for high quality necessarily. Of course, you don't want a bad reputation, so there's a balance there, and it depends on what you're doing. I mean, Twitter for a long time had the fail whale, right? It became a joke, and yet they survived, so that's kind of cool. But when you are trying something out as a startup company, you know that you're going to get something out there, and then you're going to pivot, just like Lean Startup, the book Lean Startup talks about. Or you're going to go, wow, that's really cool. People like that, they'll pay money for that. So then you're going to rebuild it. So we have built a history by design of rebuilding applications because you're not going to spend the time building high availability, high scale applications at the beginning because we consider those two things mutually exclusive. I'm either building high scale things, which take me years or months of development, or I'm building something quick time to market, which means I'm not building high scale. Those two things tend to be mutually exclusive for lots of applications.
You have App Engine and stuff like this.
Yeah. So I think Mesos actually allows us to abstract scale in a way that's unique. It's the first time, I shouldn't say the first time, but it's easy to look at building an application close to being the right way the very first time, once you understand Mesos and how it works. And you build so I think it just changes things. I certainly would build something in having just a couple of nodes, just because there's no reason not to. To me, 2 nodes is just as economical as 10,000 nodes, because the cost of adding another node when I need to, That's the whole part. That's cool. Is once I understand that this is an infrastructural change, adding a new node is just spinning up another AMI. That's a slave. And when I need another one, I just spin up another one. And there's no other administration or operations for me as a developer. It starts to eliminate ops in a way that's really awesome. Right? You're smiling like you're an ops guy. Sorry about that.
I completely agree with what you're saying.
Okay. Yeah.
Experiences.
Give me the challenge.
Well, I mean, for startups, I don't think they would even invest in hardware nowadays. They would just run Apache or whatever.
Oh, all the startups I'm working with are all in the cloud.
Mesos already, even if it's quite simple to start, it still requires a few technical proficiencies that most startups don't have.
Here's the thing. I'm trying to give. There's things I can't talk about, but I think I can talk about this, and that's Airbnb. Two of the guys that started Mesosphere worked at Airbnb. Actually, several people have, but those two did as well. And they built out their analytical tools, and Airbnb has two services, and they have two clusters. So those two services are microservices, so hitting web traffic. The other one is analytics. All the tooling for analytics were built with Mesos. Everything else was not, and it's questionable as to why not, but they built it out without it, and so they've never replatformed it, if you want to call it that. My understanding is these cluster sizes are roughly the same size. I shouldn't say exactly, but they're the same magnitude. The analytics ops is less than a person, and I understand it's like less than half a person. The other side, ops, is 8 people. So there is a difference, it appears, and that's just one company, and who knows the difference between what's necessary on the microservices side versus the analytical side. So there are definitely things we could debate, clearly. But I'm seeing this pattern over and over again. You could go to HubSpot. HubSpot, completely in the cloud on EC2, so Amazon-based. They moved to Mesos to consolidate their ops. That's all. They just wanted a simple ops screen. So they wanted Marathon and they wanted a couple other things. They just want to simplify. The benefit that they got out of it, though, is that they reduced their Amazon bill in half. And so that wasn't what their goal was, but they reduced it in half. Now that becomes an economical thing that we could. That's a solid number for one, which is great. But based on the size, which was your question, definitely would have more impact. For them, they were spending $80,000 on Amazon. Amazon's not cheap. And they were able to reduce that significantly, largely because the fault tolerance they can gain, instead of having multiple nodes, they could just get fault tolerance out of Marathon. So in areas like dev and QA, where they would have multiple instances, they could go with one. The other was from bin packing, where we could have idle machines. Instead of spinning up one instance that does one thing, I can actually bin pack. So there's some good stories there, but I still see value at the small end too. Starting out right and automating. The goal here is to take advantage of what we've learned. And what we've learned, if you look at any large company today, what you usually see is in the thousands of recipes for chef. And there's lots of reasons as to why, but I refer to those as snowflakes. There's 1,000 snowflakes. They're all unique and they're all special, right? And the reality is there are probably reasons to have some special snowflakes, but most of it is just general computational power, for which we have one recipe for all of them, and that is the slave, period. And they're provisioned with whatever they need. If it's Java, then they need it, right? If it's not, then they don't. And if you start out early as a startup company with that concept in mind, life is going to be awesome, because when you need more, you just spin up another AMI and you're done. Yeah, I can't think another way, actually, so I'd love to be challenged more on it. I'm going to move. Yes? You ran out of battery? Oh, people are tired of me.
Around a beer or something to eat, so...
Yeah, cool. Okay. Can we get this one last question then? And then we'll break. Yeah.
Let's say I want to start a test cluster of 2 nodes. How much resources do I need on these 2 nodes to run Mesos, Venez, and Microsoft?
So,
CPU, RAM, network overhead?
yeah.
How much?
Well, If you're looking just to play with it and to understand it, if that's all you're interested in, there is a wow, that's terrible font. You can go out to Playa, Mesos, and this is a vagrant instance that allow you to do it at virtual machines on your local.
My question was really about the resources, memory, CPU, and network.
Okay.
I/O, because I guess you use some I/O on the nodes.
Yep. Yeah. If you're looking to get the bare minimum, I don't know if I have the answers for that, but it's very common for us to spin up nodes on DigitalOcean or EC2 or Amazon with standard resources, so maybe 4 cores. I have VM instances that are at 1 core, so you need at least 1 core. There's some challenges because there's some really weird nuances. If you have less than 1 core advertised, certain services won't be offered. So if you have, let's say you had 1 core VM, and this is a weird nuance. It's just a Mesos thing. If I had a 1 core and I had a service that's consuming a 1/4 core, so 25% is taken up. Presumably, I've got 3/4 left, but as soon as I'm under 1 core, it's not offered. So there's some weird nuances around that you should just be aware of. You need at least a core. From a memory standpoint, I can tell you that Mesos itself is it's all written in C, and the binary is in memory is 2 megs, roughly. It will grow over time and grow over size. I shouldn't say over time, over size. So the more slaves you have at the master level, the amount of memory necessary to do its job will increase. But at start, it's 2 megs, so it's small. It's nothing. What do you need over time? I don't know that. We just, last fall we did a scale test. If you send me an email, I can get you answers. We did a scale test of, I think it was something like 50,000 nodes. I'd have to look. And one of the things I asked them to measure was memory over time. So I didn't see the report. You're jogging my memory now that I wanted to see that report. And as far as I/O, latency becomes a challenge. There are configurations for managing latency. If you have too little bandwidth or too high latency, that could be problematic. You may require some adjustments, but you can have something pretty slow and still make it work. It's a matter of what you're willing to tolerate as far as recovery goes, right? In the future, in fact, what Ben said, Ben Heinemann is the brain and the co-creator, essentially, of Mesos, Apache Mesos. One of the things he said last year, which I thought was amazing, was the last decade has been about a data center. It's been about a cluster of nodes, which we call a data center. In his words, the next decade is going to be about clusters of data centers. It's about hybrids. It's about getting multiple data centers in multiple regions to be fault tolerant across each other. But most of the tooling there is just immature, and we're just at the beginning of it. So, well, we take a break, and then.
Thanks a lot.
Yeah, you're welcome. Thanks.